All right, let's go ahead and get started then. So today we're gonna do some more factoring. Okay, so we're gonna kind of put stuff in parentheses like we've been doing for a couple weeks now. This process, factoring, very important in algebra. But we're gonna learn a new pattern today that you guys have never done before. You did not do this one in algebra 1. Okay, brand new. But and it's called sum and difference of cubes. But before we do the cubes, I just want to review our perfect squares. So we talked about this a little bit last week. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, and then it's 121 for 11 and 144 for 12. I'd say you should probably know your perfect squares up to 12 squared up to 144. I think that's probably a good thing for you to recognize. If you want to know the next two, I think the next two are actually kind of easy to remember as well, 13 and 14. 13 squared is 169, which for some reason people have an easy time remembering, 169. And then 14 squared is 196. So you flip around those last two digits and you have the next two. So 169 and 196, okay? So we used these last week. Whenever we recognize these, do you guys remember if we had something like 4x squared minus 9, then we said we can factor that into 2x plus 3. And you can go ahead and write this down right here. 2x plus 3 times 2x minus 3, correct? We were able to do that. That was our difference of perfect squares pattern. Whenever we notice those perfect squares subtracting, we kind of take away the squares, right? And then we do 1 plus and 1 minus. So it's like if it's a 4, I turn it back into a 2. If it's a 9, I turn it back into a 3 when I factor it. If it was a 121, I would turn it back into an 11 when I factor it, right? A quick note on that one. So that was good stuff from last week. If we had 4x squared plus 9, that actually is not factorable. You can't change that into any parentheses. You can only do perfect squares if they're subtracting, okay? Not if they're adding. So if you notice some perfect squares like that, but they're adding instead of subtracting, that doesn't mean you can split them up like that. Not even 2x plus 3, 2x plus 3 is what a lot of people think that is, but it's not. You're not allowed to do that, okay? Okay, so today, there's actually a kind of similar pattern with perfect cubes, okay? There are some key differences, which we'll talk about. One of the key differences is with perfect cubes, we can do it whether it's adding or subtracting. We'll get to that in a minute. And then the parentheses come out a little bit different, okay? But what's kind of important for us to know is the list of perfect cubes, okay? Now, we are allowed to use our notes on a test, so you'll have this list with you. I think the first 5 are probably good for you to have memorized, although we will have some other ones showing up on the test. But like I said, you can use your notes on the test, so just look back in that. Okay, so 1 cubed I think is really easy. It's a 1. Draw that a little neater there. Okay, 2 cubed, 2 times 2 times 2 is 8. Good. 3 to the 3rd power is 27. So 3 times 3 is 9. And then times 3 one more time is 27. 9 times 3 is 27. 4 times 4 is 16. And then times 4 one more time is 64. So I actually think 64 is a really cool number because 64 is the only number that's going to show up in both of these lists. Okay, that's pretty cool, right? It's 4 to the 3rd power, but it's also 8 to the 2nd power, okay? And then 5 to the 3rd power, it's 5 times 5 is 25. 25 times 5, well, if you have 5 quarters, you have a 125, right? So yeah, those are the first 5, okay? The other ones you might run into, I wouldn't expect you to have these memorized, but if you we'll have them on our list here. So 6 to the third power is 216. 7 to the third power is 343, and these are going to start getting really big really quick here. 8 to the third power is 512. Do I just know these off the top of my head? I actually kind of do, but I'm a weirdo. And I don't know. This is literally my job, so I wouldn't expect you guys to know these off the top of your head, okay? 9 to the third power is 729. 10 to the third power is actually pretty easy. 10 times 10 is 100. 100 times 10 is 1,000. I think 11 to the third, yeah, that's 1331. 12 to the third is 1728. Cool. Okay, so when we're looking at our perfect cubes, we're just going to be, I'll just be referencing back to this list, okay? Okay, cool. So let's learn our pattern here for perfect cubes, okay? So the pattern, and so like I said before, the pattern for this, we have a pattern for the sum and a pattern for the difference. So we can do these ones whether they're adding or subtracting, okay? Now, in both cases, actually, it's again made up of two parentheses, but instead of two parentheses of the same size, it's one small parenthesis and one big parenthesis. So oops, that's too big. So there's going to be one binomial and one trinomial. Okay? And then actually all the variables are going to be the same. So if this is a cubed and b cubed, this is going to be a and b, and that's also going to be the case over here. A in the front, b in the back. And then in the big parentheses, I have a squared out front, I have a, b in the middle, and I have b squared out back. So that's actually the exact same over here. And then we need on each one of these 3 pluses or minuses, okay? And you will have this on your notes, but there's a really cool way to remember what's plus and what's minus. So to fill out the pluses and minuses, you're just gonna use SOAP. Just use SOAP. SOAP in this case is an acronym. So it stands for same, opposite, and then the last one, which these two are kind of together, is always positive. Same, opposite, always positive. El mismo, el opuesto y siempre positivo. And I wish if that spelled out jabón, but it doesn't. So we have to do soap. All right, so what do I mean by same, opposite, always positive? Well, if we look back at this one, number 3, this one was a plus in there, correct? So that means the first one is the same as plus. So try to stay with me here. What's the same as plus? Plus. The next one is opposite. So what's the opposite of plus? Minus, right? The last one is always positive. So what's always positive? Well, that's always positive. I have had some people put a negative in that last spot. There's no reason to do that. It is always positive in that last spot. Got it? All right, well, this other one, though, was a minus, right? So I'm still going to use SOAP. So the first one is same. So what's the same as minus? Minus. What's the opposite of minus? Plus. And then always positive? Always positive. Pretty cool, huh? Good little trick. Okay, so let's start doing some factoring here using these patterns. All right, so let's jump down to number 5. So number 5, first of all, when I see a third power, this pattern automatically like jumps out to me, right? Like I should be thinking about my perfect cubes factoring for the third power, okay? Also, then I'm going to look for my numbers. Do I have perfect cube numbers here? Well, let's go back up here to my list. 125 and 16, correct? Those both show up here, okay? So I should remember 125 and 216 are important numbers here. They correspond to 5 and 6, correct? So I'm going to keep those numbers in mind, okay? Okay, so let's build our parentheses here. I'm going to build one small one and one big one. So the small ones, I'm going to take away the cubes, okay? So 125, if I take away the cube, goes down to just 5. So it's like I'm going backwards in that list, okay? Since it was 5 cubed, I take away the cubed, and now it's just 5. Now x cubed, I take away the cube, it's just x. All right, and then 216, if I take away the cube, is 6. So I'm going to put the 6 out back there, okay? All right, so that's my first parentheses. I've built that. Now to build the big parentheses, I build it off of the small one, okay? So here's how I visualize it. I think this is the easiest way to think about it. The first thing I do is on the small parentheses that I just built, take the first thing and multiply it by itself. That whole thing. 5x times 5x. Well, what is that? 25x squared. So build the small parentheses first, and then do the first term times itself. Next, we do the first term times the second term. The first term from that small parentheses times the second term. If you look back up here, this was the A, B we had in the middle, okay? So first term times second term, 5x times 6, that's going to be 30x. 5x times 6 from my small parentheses, first thing times the second thing. Now I'm going to finish it off here by doing last thing times itself, okay? So I do first thing times itself, first thing times second thing times itself. So 6 times 6 gives me 36, yes? Good. So those are all my terms. Now I just have to finish off with SOAP. So this one was a minus. So I got to do same, which is minus. Opposite, which is plus. And then always positive, always positive. This is it. This is my answer, okay? All right, we're going to do a lot more of these together. I know it's kind of a lot, but you'll get it. Just keep paying attention here. All right, next up, let's take a look at number 8. So once again, I got perfect cubes. Or sorry, number 6. Sorry, number 6. That has an 8 in it. Once again, I got perfect cubes. I know I have my x cubed. I know 8 is 2 cubed, and I know 1 is 1 cubed, right? Okay, so I'm going to build one small parenthesis and one big one. All right, let's see if we can fill out the small parentheses on your own, okay? I'll give you 15 seconds here. What goes in the small parentheses? All right, so 8 is 2 cubed, so I'm going to put 2x right here, and I'm going to put 1 right there. So that's what I'm putting in this first parentheses, a 2x, and then a 1. If you put a plus in between there, you're actually correct. I'm not going to put that yet. I always put the pluses and minuses at the very end, okay? But if you have a plus there right now, it's not wrong, it's right. Okay, so once you have your small parentheses filled out, let's really pay attention here for how we fill out the big parentheses. It's based on the small one. First thing times itself. 2x times 2x. 4x squared. Now we do first thing times second thing. 2x times 1. 2x. Now we do last thing times itself. 1 times 1. 1. You see how we kind of flow across that first parentheses to get to the second parentheses, yeah? First thing times itself. First thing times second thing. Second thing times itself. Por fin necesitamos usar el jabón. Now we need to use the soap. This one was a plus. So we do same. This one's a plus up here in the original question. So I do same. Opposite. Always positive. There we go. All right, let's keep it going here. 7 and 8, okay? 7 and 8. So, let me have you guys. I want to give you time to try this out on your own, okay? So why don't you guys try out number 7 and 8? Go over them in a couple minutes. You guys want me to show you the chart? All right, here's the chart. All right, one more minute to work on 7 and 8, and then we'll go over it. Try it out on your own, though. I will go over it, but you'll get a lot of satisfaction if you do it right on your own. You'll be like, yes, I did it. Okay, let's test this out. So number 7, my small parentheses, I got 5m and 2. So then my big parentheses, I do 5m times 5m is 25m squared. And then I do 5m times 2, that's 10m. And then 2 times 2, give me 4. All right, the signos, the signs, this one's a plus. So I do same, opposite, always positive, holla. All right, number 8. I got 3m and I get 4 in my small parentheses. Those are my perfect cubes. Once I have that, I build my big parentheses, 3m times 3m, 9m squared. 3m times 4, 12m. 4 times 4, 16. Lastly, for the signs, I got a minus here, so I'm going to go same, opposite, always positive. Cool. It's a good trick, the soap trick, huh? Yeah, that's not mine, though. Like, literally every math teacher uses that one. I have some cool tricks, like, oh, wait, no, you guys don't know about that. No, I got some cool tricks that I come up on my own, but I didn't come up with this one. All right, let's move on to 9 and 10, okay? So 9 and 10, and all the ones after that, it's going to get a little weird here because we see we have the third power there in both of these, correct? But if you look at those numbers, they are not on my list of perfect cubes, okay? So I'm kind of like frustrated here. Why aren't those numbers on my perfect cubes, okay? So here is the deal with these ones from here on out. If you see a third power that's asking you to factor, but the numbers aren't perfect cubes, here's what you need to do. Check GCF. Check GCF. By GCF, I mean, is there a number that they can both divide by? Okay. Now, what number can you check? Well, these are kind of big numbers, right? So if it's even, you can always divide by 2. Even numbers always divide by 2, so that you can always take that out if it's even, okay? If they're both odd, or it's one odd and one even, try dividing by 3, 5, 7. It's probably going to be one of those numbers. Honestly, it's usually 3 will work. Are you allowed to use a calculator for this? Absolutely yes. So let's see, 81, does that divide by 3? Yes, it does. 375, does that divide by 3? Yes, it does. So what I'm going to do on number 9 is I'm going to bring a 3 out front. Remember we used to do this, GCF? And then I'm going to divide, I get to divide each of those by 3. We did this before. So this one is going to become 27 according to the calculator, plus 125x to the third. Okay, so I GCF the 3, all right? When I GCF the 3, are these numbers now on my list? Yes. So this means now I can do my perfect cubes SOAP factoring here on this part, okay? I'm just gonna leave the 3 out front. It's not gonna have anything else to do with this problem, but I still need to write it down there. It's just gonna be like posted out front. You guys, you see those people posted out inside the 7-Eleven, posted up? It's like that. It's not really doing anything, right? But I gotta factor the inside, okay? So how do I factor the inside? Well, it's a little weird here. They put the variable in the back, but it's the same idea. So 27, if I take away the cube, is gonna turn back into a 3. And then 125 turns into a 5. And then x to the third turns into the x. So now, if you ignore the 3 out front, it's really just like all the other ones we've done on this page today. All right. So then next up, we're going to build our second parentheses based on our first one. So first thing times itself, 3 times 3 gives me 9. Three times 5x gives me 15x. And then 5x times 5x is 25x squared. All right, this one was a plus originally, so I'm going to do same, opposite, always positive. All right, I wanted to do number 11 together, so let's have you guys try out number 10 now. So do the GCF first, okay? And then you should be able to do a perfect cubes factoring on it after that. GCF first. All right, so if you get stuck on the GCF, I just showed my work there. So you should take out a 2 since they're both even. And if you divide the insides by 2, it turns into 8m, excuse me, 8m to the third minus 125. Okay, so now we need to break down that 8m to the third minus 125. So now I try that. All right, so my small parentheses, I got 2m and I got 5. So my big parentheses, first thing times itself, 2m times 2m, 4m squared. 2m times 5, 10m. 5 times 5, 25. Now we'd use our SOAP. So this one was a minus, so I go same, opposite, always positive. Beautiful. All right. right, I think we have time for one more. I wanted to do number 11, so this will be our last one. So stick with us here for one more question. All right, so number 11, we have 8 to the third power. Or sorry, we have a to the third power. So I'm thinking about my perfect cubes, right? But 4 is not a perfect square, okay? So I'm thinking these are both even numbers, right? So GCF a 2. Divide both of those by 2. We got a problem. Those still aren't perfect cubes, are they? 2 and negative 54, or 2 and 54, those numbers don't work. But check this out. Are those both insides still even? Yes. And so that means that I can take out another 2, okay? So I have the 2 I took out already. I'm going to take out another 2 and divide it by 2 again. So that means outside now I have a 4. What does that really mean? That really means that when I first saw this problem, 4 and 108 were both divisible by 4, so I should have taken out the 4 right away. But is it okay if I took it out in 2 steps? Yeah, that's fine, right? We got to the same answer anyway. So sometimes there's a bigger number you can divide by, but don't stress about that. Just like know that if that happens, you can take out 2 different numbers and then they can just multiply out front, okay? Okay, now I have a to the third and 27 here. This will break down in perfect cubes. Now in this case, there's no number attached to the variable. That's okay. That just means I'm gonna put an a there. Just a. 27 is gonna turn into 3. All right, so once I got my small parenthesis built, first thing times itself, a times a is just a squared. A times 3 is 3a. And then 3 times 3 gives me 9. This one was a minus, so I do same, opposite, always positive, and we are done.